So 9-3 was the last subject, the last section that we did before spring break. And I wouldn't say it's the hardest, but I would say it's the most tedious, where we had to do a lot of computations. Just to assume that nobody has a graphing calculator where they can enter and everything, I'm going to do this section by hand, and then afterwards I'll have an app open where hopefully everybody has access to it, and we can try to do the same problem, or maybe a different problem, probably a different problem, and it is the same process just with a calculator. So, which was the last thing we did, I think, on Wednesday before you guys left for spring break. So in 9-3, we are now testing the difference between two means, and it's a dependent sample. So it's two separate samples, but it's from the same group. So remember, when you're taking a sample of something, in order for it to be as accurate as possible or representative of the population, we have to have a random sample each time. A random sample being a random group of people, of different backgrounds, of different everything. Well, what happens if you're using the same sample? Well, that's what this section's about, when you're using the same sample every time. So the same group of kids, or the same athletes, or whatever it may be. So in this section, we're going to be really looking at the difference between the first time they took the sample and the second time they took the sample. And so we have a couple of formulas. The first one is finding the mean of the difference. All right, and this is stuff that we've sort of talked about before, but the mean of the difference is represented by the D bar, okay? And this is when you have sigma of D, or the summation of D over N. So that's the first formula. The second formula is our standard deviation of the two differences. Standard deviation of the two differences is when we have N times the summation of D squared minus the summation of D squared over N times N minus 1. Okay, and so we can use that to find our test value. Our test value is representative by T, because remember, we're working with samples still. We're not working with the population, we're working with samples. So to say T equals our mean of the differences, or D bar, minus the population average over the standard deviation from our two samples, and really the difference of it, divided by the square root of our sample size. And just remember that this right here, because it is our population, typically, if they will not give it to us, so typically it is 0. So just make sure you remember that for this. Okay, so let's go ahead and jump right into a problem. Here we have, let me just make it a little bit more. There we go, can't quite see it. All right, so here we have a random sample of 9 local banks, shows their deposits in billions of dollars 3 years ago, and then their deposits today. So it's the same sample, all right, so we're looking at the difference between the two samples. At alpha equals 0.05, can it be concluded that the average in deposits for banks is greater than it was 3 years ago, and assume that the variable is, or the variables are, normally distributed? All right, first things first, we have to make our sample, or not our samples, but our hypotheses. All right, so obviously we know that hypothesis, the null hypothesis is going to be, and now we're dealing with the population of the difference, so that's why we annotate it as mu sub D, and we know it's always going to be equal, and we're going to say that there is no difference, it equals 0, okay? Our alternative, all right, and sometimes it's hard to see, so I like to write it out. I think about it in like terms of what happened first. Well, what happened first was they took the deposits from 3 years ago. Okay, and then what happened next after that? Today we have new information, and today, okay, and then it says, can it be concluded that the average in deposits for banks is greater today? So because it's greater, I'm going to actually make my symbol a less than symbol, just to show that it is the greater hand, or like the mouth, is facing today. And so my alternative hypothesis is U sub D when it is less than 0, okay? So now I see that there is a difference, and my original is going to be smaller than today's, the original is smaller than today's information. So that's done. Now we have to use our information and go for our critical value. Critical value has not changed. It's based off of alpha. All right, our alpha is 0.05. Our degrees of freedom, if we had two different sample sizes, then we would pick the smaller of the two, but they're the same, and that's going to be equal to 9. So our degrees of freedom is going to equal to 8. So I can go to my Teams, not Excel, Teams, and I can go to Files, and I can go to my T-score. So T-score is right here, and I'll make it a little bit bigger just to make my life easier. I'll make it 125. Our degrees of freedom we said was 8, I think. Yep, it's going to be 8. So let me put my cursor right here so you can see it. All right, so we have 8, and it is a one tail, so we can come over here, and we want it when alpha is equal to 0.05. So really it's going to be this value right here, 1.860. All right, so I'm going to write that in my thing. One critical value is 1.860. And I just have to ask myself, is it going to be a positive or a negative? Well, because my sign is pointing to the left, that is the negative number. So it's really my critical value is negative 1.860. All right, now to find the test value. Remember, the test value is based off of the formula, the mean of the difference minus mu sub d, and remember this is going to equal 0, over the standard deviation of the difference divided by the square root of n. So some of these pieces we know, and we can plug them in. We know that this is going to be 0 right here. We know that our standard deviation is we'll get that in a minute. We know that our sample size is going to be 9. So we do know some pieces. We just have to figure out what's going to go here and what's going to go here. So let's go to a new screen so that we can get that first, and then we'll get the highlighted pieces that we need. All right. Let's go back here, and we will go to a new screen. All right, so here we have this, and I'm going to go ahead and start setting this up. When you set it up, you want to have your first variable, I guess you could say. Oops, that's not how you annotate that. Our first, not our sum or average. Our first variable, which is from 3 years ago, and our second variable, which is from a couple years ago. So I'm going to take a couple seconds, and I'm just going to write all this out, but I'm not going to make you guys watch me write all of these out, so 1 second. All right, so I went ahead and wrote all of these out, and now I'm going to add another column. I need to find what D is equal to. That's just the difference, okay? The difference is going to be the difference between my first variable and my second variable. So that would be 11.42 minus 16.69, and that's going to give me a negative 5.27, and I'm just going to continue all the way down. So I went ahead and found the difference really quickly, and then if later we're going to have to add all this up. So if I were to add everything up, that should give me a answer of negative 9.73. So again, all I did was I added all of these up. All right. The next thing that I have to do, my next column, is going to be when I square the difference. So I have all of my differences already written out. I just have to square all the numbers. So for example, if I were to get a different color, if I were to square negative 5.27, it's going to give me 27.7729. So I'm going to square all of these. So I squared all these, and again, I'm going to have to add all of them. So if I add all of this up, I'm going to end up with 40.55 5, 4, 3, 7. So I have all of that, and now it's time to find my standard deviation now that I have all of these pieces. Again, the standard deviation, I'm going to put this in a different color. Standard deviation of the difference is going to be the square root of n times the summation of d squared, which we did right here, minus the summation of d squared, which we did over here. All of that over n times n minus 1. And I can plug in all of this, and I'm going to color code it just so that we are all understanding where the pieces are coming from. N is just going to be the number in our sample, which is 9. Our summation of d squared is that green color, which is 40.5437. And I'm going to put that in parentheses so I know I'm multiplying that. And then subtract that with the summation of d squared. The summation of d squared is that blue. So I'm going to use parentheses, negative 9.73. Oops. And I'm squaring it. All of that over 9 times 9 minus 1. If I use a calculator, I'm just going to use that because that makes my life so much easier. You should get an answer of 1.937. All right, so we have that, and now that we have all of those pieces, we can actually plug it into our formula or for a critical value or test value. So the test value again is going to equal to T equals d bar minus mu sub d over s sub d times the square root of n. Plug in all of our numbers. Our mean of the difference, our d bar. Our d bar is the summation of d divided by n. Okay, so the summation of d was at negative 9.3, so I'm going to write in my blue negative 9.73 over 9. Again, we are subtracting a 0. Our standard deviation we found was 1.937, and we are dividing that with the square root of our sample size, which is 9. Use a calculator, and we should get a value of t is equal to negative 1.674. And I rounded to 3 decimal places because our critical value of t is 3 decimals as well. So now that I have all of those, all of that, I can go ahead and go back to my previous screen and put that as my t value. So we found from the previous screen that our t value is actually going to be negative 1.674, and now I can sort of draw my picture and make my conclusions. Again, your critical value separates your critical regions, so we're going to put this here first. We have 0, and we'll say that we have negative 1.860. Anything less than that, we're going to highlight. That is our critical region. I'm going to change the color and see where our test value lies. Test value is negative 1.674, so is it less than or greater than negative 1.8? Well, it's greater than, so I'm going to put my test marker right here and show that this is negative 1.674. And because it is in the non-shaded area, we would say we do not reject the claim. All right, so if we had our little box, our claim was an alternative, so we can cross out these, and we did not reject, so this statement in this box will be our summary, and it should say there is not enough evidence. There's not enough evidence to support our claim. And that is our answer. So it is a lot more work. I'm going to show you how to do it on a calculator next. So here's a new example. A dietitian wishes to see if a person's cholesterol level will change if the diet is supplemented by a certain mineral. 6 randomly selected subjects were pre-tested and then took the mineral supplement for a 6-week period, and the results are shown in the table. Can it be concluded that the cholesterol level has been changed at alpha equals 0. 0.10. Assume the variable is approximately normally distributed. All right, so here we have the same sort of setup. We have the same group of people. Again, it doesn't say that we, measured it men versus women. We are measuring the same people again. So we know we're looking at our difference. So first things first, let's label our hypotheses. We got our null and our alternative. Our null is always going to be u sub d for this one because we're talking about the difference between the first time and the second time equals 0, meaning there is no difference. It's exactly the same. And then when we look down here, we don't really see anything. Remember, we always look at that last sentence. We don't really see anything that tells us if it's going to be like less than or greater than. So because we don't really see that, we're going to say that it is not equal 0. We don't have any keyword. And that is our claim right there. Can it be concluded that the level has changed? Okay, so if it is different, that is our claim. First things first, we can find our critical value based off of our alpha, 0.10. Remember to divide it by 2, and you should get 0.05. And this time we are also looking for our degrees of freedom. Degrees of freedom should equal 5 this time. So we go to let's just pause that for a second. We can go to our teams. Here's our t-score. And the t-score table that I gave you actually shows you your alpha with a 1-tail and a 2-tail. So you don't really have to divide by 2 like I do, but it's good practice in case you're using a different table. So as we said before, we have a degree of freedom of 5, my bad. Degrees of freedom is 5 because we had 6 people. All right, we are coming over to when our 2 tails equals 0.1, which is not this one, but the next one, 2.015. Since it's a 2 tails, it's going to be positive or negative, so I'm going to go back to my screen, and I'm going to write that. My critical values are going to equal positive and negative 2.015. Now I have to find my test value. Instead of doing the crazy table that we did before, I'm going to use my calculator this time. So if I go to the calculator, let's just pause that for a second. Go to our calculator. I actually went ahead and put all of our pieces. Remember, once you're done, go ahead and press the right arrow and then the up arrow so you can get to that L3, and you want to tell it to subtract list 1 and list 2. Okay, remember list 1 and list 2 is in the blue, all right, above number 1 and number 2. So to get to that, you're going to click second, L1 minus second 2, which is L2. And you can press enter. And now we have all of our differences. Once we're done with that, go ahead and go to your stat button, which is right here. Click on stat. We have already edited our list. We're going to go over to test, and we're going to do number 2, which is our t-test. All right, make sure you have data highlighted, and you can go down. Again, we don't have any information about our population average, so we're going to keep this 0. We're going to go down to list. Make sure you're using the third list and not L1 or L2. So I'm going to press second and then 3 for my third list. Frequency we're going to ignore. We said it was a 2-tail, so I'm going to click on this one. And then once I'm done with that, I am going to calculate it. This way I don't have to do the table. It just gives me the answer of 1.6, as you can see right here, 1.60, and if I round correctly, 8. It might be a little different if you do it by hand. I do want to point that out because the calculator goes to like infinite decimals, as opposed to when you do it by hand, people tend to round early as opposed to later. So if you ever end up with like something really, really close, but you're just off by 1 decimal, that's usually because one person used a calculator and another person just did it by hand. So now that I have that, I can go ahead and write my answer, 1.608. 1.608. That is my test value. So now I can draw my picture. Okay. My critical values are here. This is what determines where I'm shading and stuff like that. I have it on both sides, 2.015 and negative 2.015. I got to shade left and right of it because anything beyond these numbers is no longer valid. I'm going to put my test value. It is positive. Okay, so that is off to the right of 0. And I just have to ask myself, is that less than or greater than 2.015? And it's less than, so it's going to be to the left of it. So it'd be like somewhere right around here, 1.608. And since it is not in the shaded region, we are not rejecting. So we don't reject. All right, so if we did our little table, our statement can only be the alternative, so we can cross these out, and we are not rejecting, which is this bottom one, which should say there is not enough evidence to support the claim. And that is our answer. And it's a lot shorter when you use the calculator. Again, if you're having difficulties finding a calculator to use while you're at home, please text me on Remind or via Teams or send me an email, and I will gladly walk you through what you have to do. But this is all you have to do for 9-3. Good luck, and make sure to contact if you're confused.